Hello everybody. Today I can prove segments are parallel and perpendicular by finding slope and using parallel lines have the same slope and perpendicular lines have negative reciprocal slopes. So let's go back to some of our songs because there's a couple of songs that are going to apply for this lesson. One is like half shared with the last lesson with the distance formula because for this particular lesson you need the slope formula. So let's start with the slope formula, which is half of this song, if I can find it. This is a relatively new song. I don't know if I recorded it. Here it is.
Distance equals vertical delta x squared delta y squared. Slope equals delta y over delta x. Distance equals vertical delta x squared delta y squared. Slope equals delta y over delta x.
Yeah. So, first things first, my slope formula. Slope equals delta y over delta x. The other thing you need to know for this lesson.
Parallel has the same slope, perpendicular tone, perpendicular lines have negative reciprocal slopes, negative reciprocal slopes, lifted and negated, negative reciprocal slopes. Have the same slope, perpendicular tone, perpendicular lines have negative reciprocal slopes, negative reciprocal slopes, lifted and negated, negative reciprocal slopes.
All right, so parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. That's come up in multiple lessons that we've done in the past month. And remember, negative reciprocal means flip it and negate it. You change the sign and you flip the fraction. So we're going to use the same structure we did in yesterday's lesson, but now we're going to prove, instead of congruent, we're going to prove parallel and perpendicular. Let's start with my pink, which I ended on last time. That was a blast. I like fun colors. A is negative 5, 2. B is 0, 4. C is negative 2, negative 2. D is 8, 2. It proved that AB is parallel to CD. Parallel has the same slope. Whoops, that's not what I'm supposed to be writing. Just like the previous lesson, I start with what they want me to prove. If they want me to prove that AB is parallel to CD, then I write AB is parallel to CD because, well, parallel lines have the same slope because they have the same slope. So now I'm going to calculate the slope. I'm going to calculate the slope for AB. I'm going to calculate the slope for CD. Slope equals delta y over delta x. So AB is 1, 2, 1, 2, 3, 4, 5. Up 2 over 5. Delta y is x is 2. Delta x is 5. CD, 1, 2, 3, 4 is delta y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is delta x. For slope, you always want to reduce the fraction. 4 over 10 reduces to 2 over 5. I show that they're the same. I'm done. So, to prove AB is parallel to CD, I start by writing AB is parallel to CD because, well, parallel lines have the same slope, because they have the same slope. I then have to calculate their slopes using the slope formula, and I show that they're the same. Yesterday, we calculated distance because we proved segments were congruent. Congruent segments have the same distance. Parallel lines have the same slope. Number 2, let's get another fun color to get on here. We can just go green. F is 2, 5. Let me make it bigger. F is 2, 5. I is 5, 7. S is 4, so F, I, S is 4, 2. H is negative 2, negative 2. It wants me to prove Fi is parallel to SH. So I'm going to start by writing Fi is parallel to SH because I want you to finish that sentence. Use number 1 as a model. How do you prove segments are parallel? What do you need to know about parallel lines? Finish that sentence. Take about 10 seconds to do that. Fi is parallel to SH because parallel has the same slope. Because parallel lines have the same slope. So now you're going to have to calculate the slopes using slope formula. You're going to find the slope of Fi. You're going to find the slope of HS. Do it. Pause, calculate the slopes, and then unpause. All right, now that you calculated the slopes on your own, let's get a new fun and fresh color. Let's go orange. Fi, 1, 2, 1, 2, 3. Changing Y is 2, changing X is 3. HS, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 over 6 reduces to 2 over 3. They're the same. I'm done. Parallel lines have the same slope, so to prove that they're parallel, tell me they're parallel because they have the same slope or because parallel lines have the same slope, and then calculate their slopes. Let's skip ahead to number 4. It wants us to prove that AB is perpendicular to BC. Well, perpendicular lines have negative reciprocal slopes. So I'm not going to say that they are parallel because they have the same slope. I'm going to say that they are perpendicular because they have negative reciprocal slopes. A is 2, 2, B is 4, 5, C is 7, 3. AB is perpendicular to BC because perpendicular lines have negative reciprocal slopes. Hard for me to go so deep on that. Negative reciprocal slopes. Wow. I started writing negative and then it turned into reciprocal. They have negative reciprocal slopes. So I'm going to have to find their slopes using the slope formula. Do it. Pause. Calculate the slope of AB. Calculate the slope of BC. Then unpause. Now that you calculated the slopes of AB and BC, the slope of AB is 1, 2, 3, 1, 2. The slope of BC is down 2, right 3. Now, they're not supposed to be the same. They're supposed to be negative reciprocals. Are they negative reciprocals? If I flip 3 over 2, do I get negative 2 over 3? Yes, I'm good. I'm done. I'm just showing that they're negative reciprocals of each other, and they are. Why don't you try number 5 on your own right now? You can refer to number 4 as a model. So please pause, try number 5 on your own, and then unpause. Okay. F is 2, 5. I is 4, 8. H is 10, 4. It wants me to prove that FI is perpendicular to IH. So FI is perpendicular to IH. Perpendicular lines have negative reciprocal slopes. So I'm going to say that they're perpendicular because they have negative reciprocal slopes. So now, I've got to find the slopes. Slope equals delta y over delta x. Let's find the slope of Fi. Up 3 over 2. IH. Down 1, 2, 3, 4. Over 1, 2, 3, 4, 5, 6. Negative 4 over 6 reduces to negative 2 over 3. Did I show that they're negative reciprocals of each other? Yes. If I flip and negate one of them, I end up with the other. I'm done. There's just one more thing I want to go over with you. Number 8 or 11. Let's do, it doesn't matter, they're kind of the same. Let's do 11. I feel like this one's more likely to come up within a bigger problem. Q is negative 7. Feel free, if you want to try this problem on your own without me going over it, feel free to pause and go over it on your own. Q, U, I, Z. It wants me to prove that QU is not parallel to IZ. So the symbol for not parallel is parallel with a little line slash through it. So if they were parallel, parallel has the same slope. So to prove they're not parallel, I'm going to show they don't have the same slope. QI is not parallel to IZ because they don't have the same slope. To show that they don't have the same slope, I'm going to have to calculate the slope. Slope equals delta y over delta x. QU, oh, this is a lot of counting. I'm going to go to a deeper, a sharper color. QU, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 12 over 10, that reduces to negative 6 over 5. Slope of IZ, down 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Negative 7 over 5. They don't have the same slope, therefore they're not parallel. That's it. If I wanted to prove that things were not perpendicular, I would show the slopes are not negative reciprocals. The work is the same for all these. The work, you're just calculating the slope of both segments. If they're parallel, they should be the same. If they're not parallel, they should not be the same. If they're perpendicular, they should be negative reciprocals. If they're not perpendicular, they should not be negative reciprocals. That's it, my friends. Again, you're going to see this come up later within the 6-point questions when we do coordinate geometry proofs. So right now, it's very important that we get the basics down. And if you don't have the basics, if you're not comfortable with slope formula, go back to the slope lesson. If you're not comfortable with distance, which we did in the last lesson, go back to the distance lesson. You need to know the prerequisites before you can get to this. So again, I can prove segments are parallel and perpendicular, as well as not parallel and not perpendicular, by finding slope, using the slope formula, and then using parallel has the same slope. Perpendicular lines have negative reciprocal slopes. Have a great and productive day, everybody. Until next time.